Well, continuing on with our fractional unit or rational unit, we're going to title this Fractional Equations 1. We are going to spend 2 days discussing this, and we'll start off with some pretty nice ones today, and then we'll move on to some more complex ones tomorrow. Example 1. Use the technique of cross multiplication to solve each of the following equations. So I can cross multiply anytime I have two functions equal to each other. So let's just make a note in our book here. Okay, we're going to cross multiply when we have two fractions equal. Okay, so again, I'm only doing this when I see two fractions equal to each other. So let's go for it. Cross multiply means we're going to multiply right across. So I'm going to say this is 2 times x minus 1. And then I'll multiply this way. 5 times 4x plus 5. Now notice you write the single monomial term first. If you have one by itself there, like a single term monomial, we're going to put that first. Now we'll just go ahead and solve. So I get 2x minus 2 equals 20x plus 25. And again, my goal is just to get the x's on one side, the numbers on the other. I'm going to subtract 2x from both sides. Let's see, subtract 25 from both sides. So I've got a negative 27 equals 18x. And I'll divide both sides by 18. Again, I want to get x by itself. So at this point, I'm just going to say x equals negative 27 over 18. And of course, I could probably reduce that. I can divide both of these by 9. So that's negative 3 divided by 2. Now, we can always take that answer and check it. And we're just going to take this answer, we're going to put it in our calculator. And we're going to type each side in and see if they check. All right, and we want each side to equal each other. Example number 2, same idea. X plus 1 divided by 2 minus x equals 2 over x minus 6. Okay, I have two fractions equal, so my gut instinct needs to be cross multiply. All right, now we'll get the most out of this. If you pause it, try it on your own and see if your answer matches mine. So let's pause it. So I haven't solved all the way yet, but hopefully your work is matching up to mine. I've got my nice cross multiply going on, so my monomial came first because I had that. So that get me 4 minus 2x. These two I'm just going to have to FOIL together. And of course I then want to set one side equal to 0. Now we'll simply just factor. So hopefully we're thinking 5 and 2, x minus 5 and x plus 2 equals 0. And then of course we'll tee it up. Remember you're setting each piece equal to 0. So I get x equals 5. And I'm setting this piece equal to 0. So I get x equals negative 2. Now again, because this is an equation, we're not done until we check our answers. All right, and when we check, we always plug back into the original, and most of us are pretty good at that. So I'm going to say x plus 1, and I'm going to use my calculator, over 2 minus x equals 2 over x minus 6. Okay, and I'm just carefully plugging these in. Now remember, you can use that store button. We can take 5, store it into x, and then we can just type this fraction in. Okay, and then we'll type this fraction in and see if they're equal. And once we do that, we're going to do the same thing for x equals negative 2. We can just take negative 2, store it into x. Okay, that store button's on the bottom left of your screen by your on button. And we'll type those in and see if they're equal. I did get both of them to be equal. Hopefully you did. So I'm going to say my solutions are negative 2 and 5. Now, we're going to step it up quite a bit here. Most of our problems we see this year are not going to be as simple as cross multiplying. We typically did a lot of that in Algebra 1. So here's where the real questions come in. Example 2. Consider the equation 1 over 2 minus 9 over 4x equals 3 over 4x. Here's how we solve a fractional equation. The first thing we think of, and let's get this in our notebook, is what is the least common denominator for all three fractions. All right, so if I look at those denominators, what is my least common denominator? Now we've been practicing that for a few days, so hopefully you're pretty comfortable saying 4x. Now here's the different part. All right, and again, let's get this in our notebook once nice and neat. Multiply both sides of the equation by the least common denominator to clear the equation of the denominators. Then solve using the linear equation. So at this point, why don't you pause it, make sure you get that in there perfect, and then regroup. All right, we're ready to solve this problem. So we've identified our least common denominator as 4x. So here's what the direction said. Multiply both sides of the equation by the least common denominator. So here's what I'm going to do. I'm going to wrap this side up, and I'm going to say multiply by the common denominator 4x, and I'm going to wrap this side up, and I'm going to multiply by the common denominator of 4x. Now, when I do that, something nice should happen. Remember, this is really 4x over 1. So when I multiply, I'm just multiplying the tops together. Okay, so that's 4x over 2 minus sign. 4 times 9 is 36 over, 36x over 4x equals, on my top, I get 12x over 4x. Now the whole point is I should clear the fractions. Watch what happens next. 4 divided by 2 gives me 2x minus sign. 36 divided by 4 gets me 9, and the x's cancel, equals, notice the x's will cancel again, 3. Now look how easy this equation is to solve. Let's just add the 9 over. I get 2x equals 12, and divide x equals 6. And let's box that answer in. Now that doesn't mean it always works. Remember, we have to go back and check. And we're going to check back into the original. So I've got my 1/2, this is my check, minus my 9 over 4x equals my 3 over 4x. Okay, we're just going to plug that 6 in back to check. So I get 1/2 minus 9 over, 6 times 4 is 24, equals 3 over 24. And at that point, I just want to make sure my calculator this side comes out to equal 3 over 24. You can pause it, see if it works. And I believe it did. So my solution is 6. Exercise 3. Which of the following values of x solves this equation? Now I didn't give you a multiple choice, so let's just go ahead and work it out ourselves. Now again, I'm not cross-multiplying because I don't have 2 equal fractions. I've got 3 fractions. So goal, let's make a little note here. We want to get that common, least common denominator. All right, I need my least common denominator. So take a look at them, 6, 10, and 15. What number do they all go into? I think of the number 30. Maybe you have something bigger and that's okay, but the least one they all go into is 30. So I'm just going to identify the least common denominator is 30. So let's rewrite this equation nice and neat. And now I'm going to multiply both sides by 30. So I'm going to wrap this side up. I'm going to put a 30 in front. I'm going to wrap this side up and multiply by 30. Okay? Now watch how I do this. I'm going to say I have 30 times x minus 4 over 6 plus 30 times x minus 2 over 10 and 31 over 15 times 30. Now, did you notice I didn't multiply by the 30s? And you might be thinking, well, that's kind of odd, but watch what happens if you don't do it. And I think it's pretty easy. I can clean up the 30 and 6. I can say 6 goes into 6 once and into 30 5 times. So now I'm only going to multiply by the 5. 5x minus 20. Watch the next term. I got a plus sign. 10 goes into 30 3 times. So now I'm really only multiplying by the 3. 3x minus 6 equals 15 goes into 30 2 times. So I'm really only multiplying by 2 now. 62. Now I have a nice linear equation to clean up. The 5x and 3x make a total of 8x. The negative 20 and negative 6 make a negative 26 equals 62. So that's 8x equals 88. And if I divide, x equals 11. Now again, because it's a fractional equation and it's an equal sign, I have to go back and check. So I'm just going to take this 11 and I'm going to plug it back into the original equation. And when I plug it back in, I get my 11 to check. So I'm just going to put that in my solution set. All right, so we're building. They're going to keep getting a little uglier. So the more we practice, the better we'll be here. And let's say, okay, take a look at that denominator. 1 over 10 minus 1 over x equals 1 over 5x minus 2 over x squared. Now again, I can't cross multiply because I don't have just 2 fractions. So I've got to come up with that least common denominator. All right, and that's what we want to identify first on our paper. What is my least common denominator? Well, let's start with the 10 and the 5. They both go into the number 10, so I'm going to use 10. And if I look at my variables, I think x squared, and I'm hoping you said the same thing. So I'm going to go ahead and multiply both sides by 10x squared. So I'm going to say it's 10x squared times, I have my 1 over 10 minus my 1 over x equals the 1 over 5x minus 2 over x squared. Oops. And I'm multiplying by 10x squared. Okay, now I want you to do the same thing. Do the trick where we don't actually multiply. So I've got 10x squared times 1 over 10. Then there's a minus sign. 10x squared times 1 over x equals, and I'm going to distribute this one. So I've got 10x squared times 1 over 5x minus sign 10x squared times 2 over x squared. Alright, now I know it takes a few minutes, but these equations are going to, like I said, get nastier, so if we take our time on these ones, we'll be in good shape. Now the whole point is we should clear the fraction. Those 10s clear out, and I'm left with x squared. Alright, then I have my minus sign. This 1x goes away with one of those, so I've got 10x, then the equal sign. Alright, now be careful here. The 5 goes into 10 twice, the x goes into x squared once, so I'm left with 2x. On the minus sign. Here the x squared is clear, and I get minus 20. Now I have this nice easy equation to clean up. So I've got x squared minus 12x plus 20 equals 0. We'll factor, get our solutions. So let's say 10 and 12, 5 and 2. I think I'm going to go 10 and 12, x minus 10 and x minus 2. And if I tee it up, I get x equals 10 and x equals 2. Now remember, 2 solutions means 2 checks. And when we check, we're going to check back into the original. Alright, so we're going to carefully plug those back into this original. I'll let you pause it, try it with your calculator. And again, we got to make sure we check on these. Hopefully you found the same. I got 10 and 2 to both check out. Well, as usual, we've made it to our ugliest problem of the night. We'll practice a couple of these. If you can do this, you can do anything. Like I said, these are as nasty as it's going to get. Alright, so let's get this copied in our notebook nice and neat. And hopefully the first thing that pops in your head is similar to what we've done before. Look at how ugly this denominator is here. I need to make sure I factor first. So I'm going to rewrite this out with everybody factored. Okay. And I'm going to say, let's see, if it multiplies to 15 and adds to 8, I'm going to go with x plus 5 and x plus 3 equals 9 over x plus 3. All right, now just like we've been doing, I've got this fractional equation. I cannot cross multiply because it's not one fraction here, there's 2 of them. So I've got to get my least common denominator. So off on the side, we want to make sure we always state what we think our LCD is. All right, look at those denominators. You need one of everybody. So in my head, I'm saying I need to have an x plus 5 and I need to have an x plus 3. Okay, so remember, I need one of everybody. All right, so my goal now is to multiply every side here by x plus 5 and x plus 3. So I'm going to wrap this side up and say x plus 5 and x plus 3. And I'm going to do the same here. I'm going to wrap this side up and say x plus 5 and x plus 3. Okay, now I know it's a lot of writing. We're just going to have to get used to that. We've been doing a great job so far in class. So now I'm going to take this term and I'm going to distribute it to this fraction, and then I'm going to distribute to this fraction. Now remember, I'm not actually going to multiply them. Let's just write them down. X plus 5, x plus 3, and that's times x plus 1 over x plus 5. Then I've got my plus sign. We're going to do it again. X plus 5 and x plus 3. And I'll multiply that by my 18 over x plus 5 and x plus 3. And we'll do it again. We're going to multiply that x plus 5 and x plus 3 by this fraction, 9 over x plus 3. All right, we got them all written out. Now watch the beauty. Our goal is that we clear fractions. So you'll notice that this x plus 5 clears with this x plus 5. So I really have x plus 3 times x plus 1, and we'll just multiply that out quickly. So that's x squared plus 3x plus 1x plus 3. Okay, then I'm just going to carry this plus sign down. Look at the beauty here. We clear the x plus 5s and we clear the x plus 3s, so I'm left with just the number 18 equals. On this side, we'll clear the x plus 3, so again, no fraction, and I'll have to distribute that 9. So I'm going to say 9x plus 45. Now we have this nice simple equation to solve, and my goal is to set one side equal to 0 when I have that x squared. So I'm going to say I have x squared. 3x plus 1x is 4x. I'm going to bring this 9x over, so I'm going to say minus 5x. I have 3x plus 18. I'm sorry, not 3x. I have 3 plus 18, which is 21, minus that 45 that I bring over. So I'm going to say minus 24. Hopefully you'll agree equals 0. We'll factor this bad boy. Let's see, I've got 6 times 4, 2 times 12, 3 times 8. I think that's my winner. 3 and 8. If I want a negative 5, a negative 8, and a positive 3, we'll tee it up. I get x equals negative 3 and x equals 8. Now remember, just because you get those two answers doesn't mean you're done. We got to go back and we got to check them out in the original. Alright, so I got to copy that original problem down, and I've got to carefully plug them in. Now, I do have one little trick for you. If we look at that original problem, and I'm going to rewrite it here, I'm going to show you a quick way to reject any answers. Watch this. And you should probably start the problem off doing this, and this will help you with your rejections. What makes this fraction undefined? Well, we're going to say x cannot equal the number negative 5. Now remember, that's when you set your denominator equal to 0. And same thing here. Would you say negative 5 again? How about on this term? What makes that fraction undefined? X cannot equal negative 3. And same there, x cannot equal negative 3. Well, here's the deal, guys. This is how easy this is. If you get one of these answers, you have to reject them because we know that's when our fraction's undefined. So look at the two answers you got, and are you going to keep both? I'm going to say this one automatically gets rejected because x cannot equal negative 3. Therefore, the only answer that should work would be 8. All right, so watch that undefined trick. And we're going to start our problem off by saying what x cannot be from now on. All right, let's dive into another one. All right, so let's keep building. Next question, what is the solution set of this equation? Now, again, fractional equation, we're going to have to rewrite and find that least common denominator. So let's go ahead and rewrite this. And remember, let's factor that denominator. Okay, that's got to be my first move. And let's see. Multiplies to 12 adds to negative 1. I'm going to go x minus 4 and x plus 3. Alright, now, like I said, before we get that least common denominator, let's talk about what x cannot be. And look how much that helps us with our multiple choice. So remember, what makes this fraction undefined? I'm going to say x cannot equal the number 4. And what makes this fraction undefined? X cannot equal the number negative 3. And obviously it's the same in those. Now look at your choices. You just said x cannot equal 4 and x cannot equal negative 3. Could you reject a choice just based on that? Yes. I could kill this choice, bam, and this choice because I just said x cannot equal 4. So do you see how beneficial it is to know the word undefined? Alright, let's go ahead and talk about now our least common denominator. Staring at these denominators, I would say my least common denominator, and let's jot that down, we want to make sure we write that down every time so the grader knows what we're doing, is x minus 4 and x plus 3. Alright, so let's give these a big bear hug each side here, and we'll multiply by x minus 4 and x minus 3. And we'll wrap this bear up here, and we'll go x minus 4 and x plus 3. I think I said a minus 3, I do mean a plus 3 there. Alright, why don't you pause it, take your time, and write it out. There's one other bear trap hidden in there. Hopefully you saw it. Don't let this get you. Remember, we're going to change that negative to a positive and make this guy negative. Alright, so let's go ahead, pause it, write out your new equation. Alright, so back in the game here, I hope that looks like mine, or mine looks like yours, I should say. And let's see what we can clear. Remember, that's our goal, is to clear fractions. So I can clear the x minus 4s. And now I have to multiply this term and this term. So as I distribute, I should get x squared plus 3x. And I'm going to clear the x plus 3, so just be careful. It's negative 1 now times that quantity. So I'm going to get a minus x plus 4 equals, and I love when I get to clear both the x minus 4s and the x plus 3, so I get equals 28. All right, let's set that one side equal to 0. So I've got x squared, 3x minus x is a plus 2x, and if I bring that 28 over, I get a negative 24 equals 0. All right, we got some nice factoring going on here. Let's say I can go 6 times 4, 8 times 3, 12 and 2. I think I'm going to go 6 and 4, x plus 6 and x minus 4. And when I tee that up, I'll get x equals negative 6 and x equals 4. Now remember what we said in the beginning. What made that fraction undefined? Well, we said x cannot equal, let me scroll back up here, x cannot equal 4 and x cannot equal negative 3. Whoa, baby. X cannot equal 4 and x cannot equal negative 3. So I can reject my 4 and my only answer should be negative 6. And let's hopefully see if that's a choice. And there it is. I'm going to only go with negative 6. Alright, so again, that benefit of knowing the word undefined can usually cancel out or clear out some of our multiple choice answers as well. Well, here we go. This is the last one for the night. My hope is that you can pause it, do it on your own, play it back, and see if it matches with mine and that you're in good shape. So let me just remind you of a few things. Let's get our state when our fraction is undefined, and let's find our LCD first. Alright, so the first thing I did again was state what x cannot be. Hopefully you agreed with that. And my least common denominator. If you've got that, I'm hoping we're in good shape. We're just going to wrap these bears up here and multiply each side by that least common denominator. Alright, so again, pause it, see what you get. Alright, well I've got mine all written out and I've cleared my fractions and I'm hoping yours looks like that. And let's see, I've got x squared minus 4x equals 0. I'm going to pull out a nice GCF of x, and I've got x minus 4 equals 0. We'll tear up. There's an x on this side, so remember you get x equals 0. And here, hopefully, you get x equals 4. Now, don't forget what you said x cannot equal. Go back and look at that. We said x cannot equal negative 6, and x cannot equal 2. Now, did we get a number like that? No. So that just means, oops, hopefully, that both of these check out. X equals 0 and 4. And again, I can check on my calculator, but I'm just going to reject those ones automatically where my fraction's undefined. Well, like I said, that's going to do it for us tonight. We've had a lot of great practice, and this is just day 1 of fractional equations. So feel free to meet us in the morning for any questions, and have a great night.